Hello, let's continue our Sudoku adventure with Fördubblad Sekvens by rockratzero. That's Swedish for doubled sequence. So this is the continuation of our doubler week, our theme week for November. So it is doublers with sequence lines. If you know what that means, you can go ahead and check the link and start solving. Otherwise, I will go over the rules right now in detail. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have sequence lines in the grid. So these purple lines are sequence lines, and it is a sequence of values in order with a constant difference between adjacent numbers. Each line may have a unique difference. So this could have a difference of 2, this could have a difference of 1, this could have a difference of 3, for example. But, the simplest sequence would be 1, 2, 3. We could also do 1, 2, 3 this way. What we can't do is 1, 3, 2. It's not a Renban. It has to be in order. We could also go 1, 3, 5. That has a difference of 2. So that's sequence lines. But sequence lines in this puzzle go off value, not digit. So what does that mean? Well, there are 6 doublers hidden in this grid. We have to find them. Every row, every column, and every 2x3 box has exactly one doubler. So if I put a doubler here, then the rest of the box, the rest of the row, and the rest of the column cannot have a doubler in it. Maybe it has a 2 in it. When we want to talk about the value of cells, this cell would have a value of 3 because it doesn't have a doubler on it. There's a 3 placed in it. That should be pretty obvious. Doublers double the value of the digit within it. So the value of this cell is 4 because we have to double the 2. So for the purpose of the sequence line, not Sudoku, we still can't repeat the 2 in the column. That's not allowed. But for the purpose of the sequence line, this counts as a 4, not a 2, because it's on a doubler. We have to find the doublers. So that's our job. The other thing with doublers is that every digit is doubled exactly once. So we can't repeat the 2 in our doublers. This could be a 1, this could be a 3, etc. But we're going to have 1 through 6 exactly once in the doublers because there are 6 doublers. All right, so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I'm thinking about these sequences. I wonder what to start with. Maybe this long one. 1, 2, 3, 4, 5, 6. So, this could just be 1 through 6. So, we only get up to 2 doublers on here. So I suppose we could double the 5 and double the 6 to get 10 and 12. But if we have 10 and 12 on the sequence line, then we'd also need an 8. So we could double the 4 and double the 5. That would get us 8 and 10. But there's not enough digits there. We'd have to do 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That's 5 digits. There's 6 digits on this line. So I don't think we get to do 2 doublers on here. Or if we do use a doubler, it's not exceeding 6 anyway. We could do doubled, like we could do a doubled 3 and a doubled 4, but that's not. Okay, I think one thing that we definitely want to point out is that this cell here, whatever digit goes in here, let's give it a color. It's going to be a little confusing with, let's not use purple. Let's give it a color. It's going to be a little confusing because we're going to use green for doublers. But just for now, this yellow, whatever goes on in the yellow cell has to end up in this box somewhere, and it's not here. So it's going to end up on its own line. So either this is doubled or there's a doubler over here that's the same value. And I have to think about the consequence of that, but I'm wondering about so this is the one that's not included on the line. This sees the whole line. This is the digit not on the line. Can I do 2, 3, 4, 5, 6, 7? No, I can't get to 7. In fact, if I include a doubled 4 to get to 8, then I'd have to, I don't think I can do 2, 4, 6, 8, 10, 12. 8, 10, 12 is too many doublers. I really think we're just a sequence of increasing by 1. 1, 2, 3, 4, 5, 6. This can't be the biggest. Okay, that's the other thing. This can't be the biggest of the sequence. This has to be the smallest of the sequence. Because if this was the biggest of the sequence, then that means we're doubling the biggest of the sequence somewhere in the middle of the sequence. That makes no sense at all. This is a digit. This is even. Regardless of whether, or this is either a non-doubled even number, that's the smallest of the digits, or it is a doubled number that is from 1, 2, or 3. So this can't be a 3. So this is definitely from 1 or 2. Because, let's see, 1, 2, 3, 4, 5, 6. Can I do 2, 3, 4, 5, 6, 7? No, I can't put a 7 on here. Yeah. Okay. Well, okay. Yeah. So because we can't increase by 2, because we're increasing by 1, the biggest number is going to be 6. And we know, well, actually, we know that this number is not doubled because it'll either see the doubler here or this doubler. This also sees the whole line other than itself. So this is a 6 and it's not doubled. First digit, 4 minutes in. Okay. I figured it out. This is interesting though. So we're going to go 6, 5. Okay, all the odd numbers are not doubled. 4, 3, 2. This is a 1, and it's not doubled. And we double the 1. There we go. We double the 1, and then this is the 2 that's missing, and then this is 4. I think that's the only way this resolves. Okay. I'm pretty happy with that. I think that's logical. There's a 1 down here. Not doubled. Okay, so placing the 2 on here, that makes me think we should do this sequence. This is the smallest number of the sequence. We can't go 2, 3 here. So we're going 2, 4, 6. Could we go 2, 5, 8? So if we're not doubled at all, let's ignore doublers for a second. We could go 2, 4, 6, or we could go 2, 5, 2, 4, 6 only. If we're going to include a doubler, this would be doubled. We go 2, 5, and then doubled 4 to get 2, 5, 8. Could we do 2, 6, 10? Yeah, this would be a 6, and then this would be a doubled 5. If this was doubled, this would also have to be doubled, and that's not allowed. So this is never doubled. Okay. Because it can't be 3. Can it be a double 2? Wait, it could be a double 2. If I double this as a 2, that's 2, 4, and then this can be a 6. Okay, so this can be doubled. Never mind. Yeah, it's really easy to make mistakes with doublers. There's a 3 down here. Oh, let's fill 1, 2, 3, 4, 5, 6 here. Maybe that's helpful. Yeah, this is interesting. This is the smallest, and this is the largest. So this is not 3, and this is not 1. Well, hold on. Let's consider doublers. I can't double the 3, that's for sure. There's a 3 on here, and I can't double it, or this isn't big enough, because this is the largest. So there's a non-doubled 3 on here, but if I put it here, I could go 3, 4, 5. Okay, there's a non-doubled 3 on here. It doesn't even have to, okay. If this was the 3, I could go 1, 3, 5, or 2, 3, 4. This is never 6 then. Because 6 down to 3 doesn't work. Oh, I could go 6, 4. No, if I went 6, 4, 2, I wouldn't have a 3. And I need a 3 here. So this is not 6 for what it's worth. Ooh, this is really tough to think about sequence lines. Maybe this line is helpful. There's no 3 on it. We're not doing 1, 2, 3, 2, 3, 4, 3, 4, 5. We're not doing 4, 5, 6 because of this cell. So we can't achieve the 3 by doubling. We're gonna have to skip over it. Would 2, 4, 6 make sense? Yeah. Would... I feel like there's other options. I could double the 1 to make a 2 even. Yeah, like... Does it have a 5 on it? I don't think it can have a 5 on it, unless we could do 2, 5, 8. Ooh, we could. 2, 5, and then double the 4. Oh my gosh, okay. Wow, sequence lines with doublers is crazy to think about. This does not have a 1 on it. These are not doublers, we should mark that. This is the middle digit of a sequence, and it's not 3 or 4. And the starting digit's not a 1. There's no 1 on here at all. So, hold on. Can we do any traditional without... Does this have to be a doubler, is the first question. If this was not a doubler, what could we do? We can't do 1, 2, 3, there's no 1. We can't do 2, 3, 4, or 3, 4, 5, because the middle digit can't be 3 or 4. 4, 5, 6 is possible. So if there's no doubler on here, this would be 4, 5, 6. This would be a 4, 6 pair with a 5 here. If this is a doubler, it's even. Could double the 2 to make 4, and then we could do 3, 5. Oh, we can't do 3, 5. Can this ever be 3? That's what I'm trying to figure out. If we double the 5, that's 10. That's, you know, that's not the middle of anything. So we could double, we can't double the 1. It can't be a 1. We could double the 2, but it'd be a 4. So, and then we wouldn't be able to use the 2 again. So we'd have to do 3, 4, 5, but we can't put a 5 here. I'm pretty sure that's accurate. So this can't be doubled. Which means this, yeah, I don't think this can be doubled at all. That places this 3. And then this has to be 2, 4, 6. No. I'm wrong. This has to be 4, 5, 6. Yeah, 5 with a 4, 6 pair. That's what it was. This is a 2. Don't know which is doubled. Let's get this pair here. We need a 3. Sorry, we need a 2 and a 3. Oh. We need a 4 and a 5. We need a 1 and a 6. Okay. This feels interesting. I think we have to double one of these. I don't think there's a sequence here. Wait, no, there might be. 1, 3, 5 is a sequence. One, 3, 5 works. Does 6 work? 6 doesn't work. So this is, okay, this is not doubled. This can't be a 6 then, because this is not doubled. So it's gonna be smaller than that and that if that's a 6. So this has to be a 1. We know 1 is not doubled because it's already been doubled. So now we're either increasing by 1 or 2. We either go 1, 2, 3, which we can't do, or we go 1, 3, 5, which we can't get to 5 by doubling. But now this is, oh, in order for this to be a sequence, this has to double to a 6. Nice. So then now this 6 is doubled. Okay, that's good progress. This is from 4, 5, 6. These are from a 1, 2 pair. That's a 1, 2 pair here. So these are from 4, 5, 6. Ah, so this is only 5. That's helpful. This is a 1, 3 pair. This is 2, 4, 6. Okay, we have everything penciled. I can't do 2, 6, 10. Why did I think this could be 6? Did I just pencil it? I don't know. So if this went 2, 6, you just add 4 again. This can't be a 10. Oh, because I got rid of the 5, so now this can't be a 6. Okay. I think 2, 8. I don't think this can be doubled. Can this be doubled? If this was doubled, we'd go 2, 8. The difference is 6. This would be way too big. Can't double it again. Yeah, this is not... Why did I think this could be a doubler? Maybe when it could be smaller? When it could have been a 2, it could have been a doubler, but now it's not. So either 2, 4, 6 or 2, 5. That's adding 3. So 2, 5, 8 with this doubling as a 4. 1, 3, and 6 have been doubled. Okay. How about this sequence? 1 to 5. Ooh, this could be 4, 5, 6 with this doubled. No, sorry, I need to gray out more of these cells. That's definitely something I need to do. 4, 5 pair means that's not a 4. 1, 2, 3 triple, so we need to put the 6 here. That's 4, that's 2. We know that 6 can't be doubled. So this is the doubler for the column. So it can't be a doubled 3. These would both be smaller than it. So the 3 goes here. Okay, let's do as much Sudoku as we can. So these are not doubled. Yeah, so the 2 and 4. The 3's already been doubled, so that can't be doubled again. So we know all our doublers. This can't be a 4 or a 6, so this has to be the doubled 5. This has to be doubled 2. There we go. And we got the correct solution. Wow, didn't even have to think about some of these sequence lines. Just what was possible. Well, that collapsed quickly, but it took me a while to solve. All right, well, yeah, I think I spent a long time trying to crack what was going on with this line. It was pretty clear that's how you had to start, but yeah, sequence lines are really hard to think about, even without doublers, but with doublers, holy cow, that was tough. Okay, well, I don't know how you set this, Rockrat. That must have been very difficult to set as well. Because just to let you know, this whole week, because of the use of doublers, could not use much tooling to help set these. These were set by hand without any substantial computer assistance. So very nice. I enjoyed this. I hope you did too. And if you did, then why not leave a like, subscribe, and a kind comment below.